We are working on constructing arithmetic sequences today, and this goes with lesson 4.2 out of your HMH textbook. Your essential question, what is an arithmetic sequence? We kind of defined this already on Tuesday, okay? And so now we're keeping to define it even more. That's weird language, sorry. Your learning goals. I can identify a rule for an arithmetic sequence that models a situation. All right, so we're just going to jump right into an interactive slide here. And so this is a real life example of an arithmetic sequence. So we have this website where you can buy tickets to go to the movies. You know, this is pre-coronavirus, to go to this theater online. And there's a $2 fee per order. So every time you make an order, no matter how many tickets you get, they're going to charge you $2, like a flat fee. And matinee tickets cost $10 each. So the total cost in dollars of ordering N matinee tickets online can be found by using, and this right here, this is a function, okay? It's our cost function. The fact that there's a C here instead of an F, that's okay. You can have all kinds of different letters here for functions, but it is a function. So C of N equals 10N plus 2. And it's 10N because 10 is the cost of one ticket, N is the number of tickets. So if you buy 5 tickets, it's 10 times 5, $50. If you buy 18 tickets, it's 10 times 18, $180. But no matter how many you buy, at the end you have to add on this $2, which is just a flat fee. All right, and so we have this table for our function, which is also a sequence, an arithmetic sequence. And for tickets, 1 ticket, 2 ticket, 3 tickets, 4 tickets, what would the total cost be? If I go and I want to order 1 ticket on this website, well, I take the 1 and I put it into the function. This is just like our warm-up, right? 10 times 1 is 10. 10 plus 2 is 12. So right here, I'm going to type 12. Now, everybody can go and type 12 right now in this first box, and you're participating. If you think you could figure out these other ones, I want you to try them. But everybody should be typing 12 right now, okay? So go to your Pear Deck tab or go to your Pear Deck window, however you have it set up. I am going to go see if I can find some people that still need to open this because there's 26 here, so we are still missing 3 people. I don't know if I have you on GoGuardian. I'm going to go try to find you. So everyone should be in their Pear Deck tab. I found somebody. Isaac A., are you using a second device? Maybe where your Pear Deck is? Yeah, okay. That works. I can't see everyone's devices on here, so I can only see your Chromebook. Scott, are you using a second device? Up to 18 out of 27 responses. And so this whole presentation during our synchronous time together today, I'm going to keep it on teacher pace mode where I'm controlling which slide you're on. So, you know, if you need to go back and add more to any of these slides, you can do that once we get into our async time, and I'll switch the way that it's set up. So instead of teacher pace, it'd be student pace, and you could go to any slide at any time. But right now I have you guys kind of limited where you are. And so we're up to 19 out of 28 responses. Write something, type something. If you're just typing 12 in this first box because that's all you understand, or that's what I'm asking you to do, you don't even necessarily need to understand why it's 12 right now, but I'm telling you, type 12 in this box. Okay, all 28 of you. I'm going to show some responses here. All right, so this first person, they have the 12 here. Good job. The rest of this is a little bit off. Let's see. 12, 22, 32, 42. Good job. All right, that is definitely the total cost. That's how your table should look. Let's see if anybody got to this next part here. What is the domain of the sequence? We kind of talked about this on Tuesday. All right, the domain of the sequence is like the domain of the function. What are your inputs? What are your inputs? Aha, here's one. 1, 2, 3, 4. I got these numbers slightly off, but 1, 2, 3, 4 is the domain. Okay. Some of you just put 12. Okay, so you're listening. Thank you. 12 is here, just to kind of clarify why again. If you take the number of tickets, this is n, tickets are n, and it's 1, so I put it into the function. 10 times 1 is 10. 10 plus 2 is 12. That's where the 12 came from. All right. This person has everything correct. Okay, so good job. We're going to move forward to the next slide. So if you didn't quite finish this, you can always come back to it later. So slide 3. So total cost is filled in. The domain is filled in. So domain and range, those are two things that go together. It's like inputs and outputs. Domain and range. The x values and the y values. You guys remember this from functions? So the range of the function is going to be the range of our sequence. And so if the domain was 1, 2, 3, 4, the range is these numbers: 12, 22, 32, 42. All right, so even if you don't understand how to do any of the rest of this, right here for range, you're going to type 12, 22, 32, 42. That's our range. Domain and range, input and output, x's and y's, different ways of referring to the same thing. And then on Tuesday, we talked about what a term of a sequence is. So it's asking you, what is the first term of the sequence? So using your data above in the table, what number would go here? And then for part D, you don't have to know anything about sequences to do this. Find the difference between each two consecutive terms in the sequence. These are just 3 subtraction problems for you. 22 minus 12, what does that equal? 32 minus 22, what does that equal? 42 minus 32, what does that equal? We're just pulling out values from the sequence, from the range, okay? 22 and 12, notice how they're consecutive. 32 and 22, they are consecutive. 42 and 32, they are consecutive. What is their difference? So I'm up to 12 responses. Let's try to get everyone to respond. That'd be awesome. Up to 16. Okay, we're up to 18 out of 29. So as soon as you click on this and you start doing anything, it counts as a response. So if you're one of the, let's see, 11 people that haven't started typing anything yet, what are you doing? 10 more people. Let's look at some responses. Okay, range of the sequence, 12, 22, 32, 42, yes. First term of the sequence. I like how they wrote this. This is interesting with the ordered pair, but it's not entirely correct. But this is where you look to find the first term of the sequence. So it's actually just one number. So the first term is actually one number. And that one number is just 12. Just 12. Okay, so our sequence, if we just want to talk about the sequence, it goes 12, 22, 32, 42. And the difference between each two consecutive numbers, you should have 10, 10, 10. Absolutely. Okay, and we talked about this on Tuesday when we looked at a sequence. We're trying to see how much does it increase by each time you move forward. Okay, if I start with 12 and I add 10, I get 22. If I add 10, I get 32. If I add 10, I get 42. That's why this difference, and we're going to call that amount, the difference, is increasing by 10. Okay, good. So some vocabulary now that we kind of reviewed what we learned about on Tuesday and learned this new thing here, the difference. So here's your vocab. Arithmetic sequence. This was defined on Tuesday a little bit differently, but both definitions are accurate. The difference between consecutive terms is always equal. So if you have a list of numbers where you're increasing by the same amount each time, that's an arithmetic sequence. And then the common difference is the difference between consecutive terms, and we write it as little d. And that's what we found in this last example. That's what this 10 was. We were finding the common difference. Now, today when we construct these arithmetic sequences, there's two ways you can write the sequence rule. So we can write an explicit rule, or we can write a recursive rule. Now, these are two different types of rules that will actually provide the exact same sequence. And I'm going to color code it throughout the whole set of notes in this lesson today. Okay, so explicit rule is going to have this blue box around it. That's where the nth term of the arithmetic sequence is defined as a function of n. And a recursive rule with the green box around it today is where the first term of the sequence is given to you. The first term has to be just given to you, like f of 1, the function at 1. What is the first term in the sequence? And also we have to define the nth term by relating it to a previous term from the function. So here's an example of that. We are going to see how we can write a recursive rule and an explicit rule for the sequence described by each table. Well, there's only one table. This is one example. The table shows the monthly balance in a savings account with regular monthly deposits. The savings account begins with $2,000 and $500 is deposited each month. So if we want to know how much money is in, say this is our account, we're saving money, you know, a table of values is a good way to figure out short term. So I know at month 1, I have $2,000 because it tells me I begin with that right here. And then next month, I have $500 more added to 2,000. So now I'm at 2,500. Month 3, I'm up to $3,000. Okay. If I want to know how long is it going to take me to get $5,000, well, maybe just a table of values would be pretty easy because I just keep going on here. 6 is 4,500, and then 7 is $5,000. So at 7 months, I have $5,000. But wonder if I want to know 10 years from now how much money I have. 10 years, 12 months in a year, that's 120. So it would not be practical to keep making this table go out 120 more times. That's hard work. We don't want to do that. So there's these other ways to write general rules to find out what we want to know. First, we're going to look at a recursive rule. All right. The recursive rule is where we have to know what the first term is, and then we have to be able to write the function that depends. I'll come back right here and show you. Recursive rule, the first term of the sequence is given, and the nth term is defined by relating it to the previous term. So with both types of rules, you always have to figure out two things. All right, so one thing you have to figure out is what is the first term, what's f of 1, and what's the common difference? So the first term, f of 1, when n is 1 and I put it into the function, I have 2,000. So f of 1 is 2,000. Common difference, how much do I add each time moving forward? 500. Once I know that, then I can put them into this recursive rule way of writing it. And there's actually a formula for this that you're going to see. So the recursive rule is f of 1 equals 2,000, f of n equals f of n minus 1 plus 500 for n greater than or equal to 2. For the explicit rule, since d is always multiplied by a number equal to n minus 1, you can generalize the result from the table. So our explicit rule is f of n is equal to 2,000 plus 500 times n minus 1. And so these are two different rules that we could use to find any value in that table for any value of n, any number, 1,000 months away from now. We can plug it into either of these and figure it out. They give us the same results. Okay, so with all of that, and I'm going to put you on the student pace mode for just a second here, right? Because you may want to go back to the definitions. You have two dots. You have a green dot and a blue dot. I want you to drag the green dot over the example of a recursive rule. Okay, so one of these white boxes has an example of a recursive rule. And then I want you to drag the blue dot over the example of the explicit rule. One of these has the explicit rule. You can go back to the vocabulary, okay, or even go back just a slide and see what those rules look like on the last slide. I have 9 out of 29 responses. All you have to do is move dots. You can do it. We have 19 out of 29 responses. 10 more of you. Move some dots around. Which one is the example of a recursive rule? Which one is the example of an explicit rule? Okay, kind of stalled out at 19. So let's see what we came up with. All right, so it looks like there's more green on the left and more blue on the right. And that would be correct, okay? Because the left, this is a recursive rule. And the right, this is an explicit rule. If you're still kind of confused about why, you can come in the chat and type, or you can come off your mic and tell me. Just look at the left and the right-hand side. What do you notice is different? What's different? Because that difference, or differences, those differences are what makes an explicit rule versus a recursive rule. How are they different? Everybody being shy. You can just type in the chat. Do you notice anything different from the left side and the right side? The left side is longer, more complicated. There's two things on the left. The one that has more numbers. Okay. N's value is given on the left. Okay. So a very short way to say, like, the left side is more complicated. Notice that we have to have actually two like equations here. All right, we have to know what f of 1 is. That has to be defined. And then we have the actual rule after that. F of n equals f of n minus 1 plus 7. So this is the more complicated one, so that is the recursive rule. And over here, the explicit rule, we don't have to know what f of 1 is. Also, it's simplified in that the right-hand side of this equation does not have a function in it. 58 plus 7 times n minus 1. There's no function here. There's no f. On the left-hand side, if I look at the general f of n, the right-hand side of the equation, there is a function of n in it, a function of n minus 1. So this is dependent on the previous value. Okay, so this is recursive, and then this is explicit. Okay, good. All right. And so, you know, when I was like making these up for you guys, it's like I haven't done this stuff in a little while. So I'm like looking at it, and I'm like, how can I try to make this, you know, clear for you? Because it's a little daunting. So this page right here, up at the top, this green box here, this is a general recursive rule. So think of this like the cheat sheet, like basic formula that you can always use to get a recursive rule. Given f of 1, f of n equals f of n minus 1 plus d, or n greater than or equal to 2. So all you have to know is f of 1, the first term of the sequence, and you have to know d. And then you can just write it. So there's an example here. Here's a sequence. 100, 88, 76, 64. Okay, the first term is the first value. It's 100. So f of 1, recursive rule, is 100. F of n equals f of n minus 1. Now, the only thing they plugged in that's different is they put plus d. The difference here, since this sequence is getting smaller each time by exactly 12, is negative 12. So they wrote minus 12. So they only plugged in two numbers into this general formula. They replaced, they put in 100 for f of 1, and then they replaced the d with the common difference of negative 12. And then you have a general rule. Here for the general explicit rule, you only have to know two things as well. You only have to know f of 1 and d. F of 1, first term of the sequence, is 100. The common difference in this case is negative 12. So the explicit rule is f of n equals 100, replace f of 1 with the number 100 because it's the first term, minus 12, okay, because I'm technically adding the common difference, so it's plus a negative, or minus 12 times n minus 1. So when you have these rules, and you can figure out for any value n, you just plug it in and you will come up with a numerical answer. Our class always goes so fast. Okay, so we have 5-ish minutes. So I'm going to give you 1 minute to choose. I think it's A, B, or C, or D. No, just A, B, C? I think it's just A, B, C. I think I only gave you 3 choices. So go to your Pear Deck tab or your Pear Deck window, and using this table, pick the explicit rule for that table. And just because I put it in here so you can see it again, the general explicit rule is here and the general recursive rule is here. So I'm going to stop student pace because I do want everyone on this slide right now. About 30 more seconds, pick one. It's okay if you're wrong, just participate. It's okay to make mistakes, we're learning. Is it A, B, or C? So most of us are picking B. Let's look here. So just kind of ignore the rules for a second and just look at the table. Okay, I just told you guys that you have to know two things to figure out the rule. You have to know what f of 1 is, and you have to know what the common difference is. F of 1 in this table is what? You can type it in the chat. What is f of 1? What does f of 1 equal from the table? Thank you, Matthew. You're correct. It's 8. Okay, 8. So right here we have to have an 8. And then what is the common difference? What are we adding each time? Yes, 4. Okay, so we have to have a 4 right here. So when you're picking your choice, it should be f of n is equal to 8 plus 4 times n minus 1. So it's actually A. A is the correct answer. A is the correct answer. You could change your answer. A. A. So that's an explicit rule. Now we're going to look at the same exact table, and we already know that f of 1 is 8, and we already know that the common difference is 4. But this time, we're going to write a recursive rule. So that's this general form here. You're going to pick, it's multiple choice. What is the recursive rule that matches the table? 3 choices, A, B, or C. About half of you responded. We're kind of split. F of 1 is 8. It's the same table. Okay, so given f of 1 equals 8, of your choices, I really didn't give you much ability to eliminate any answers here because all of them start with f of 1 equals 8, right? But for the difference that we add, the difference is still 4 because we're adding 4 each time in the sequence. So it can't be C because we're not adding 8. It's either A or B. The only difference between A and B is the operation between n and 1. Are we supposed to have n minus 1 or n plus 1? N minus 1. N minus 1. Okay, so it's A. It's A again. Okay, I will put you back into student pace mode. All right, and then you can take a 5-minute break. Our meet is technically over, and if you have any questions, you can stay on the meet. Otherwise, you're free to go and then come back after your 5-minute break and do your notes or work on any missing assignments. Have a great weekend. Bye, Lillian.